over to you.
Okay, so it's very difficult to tell in 20 minutes a lot about time series. And I decided to make the presentation a little bit more exciting. I include some surprises that we will see during the presentation. So since we only have 20 minutes, I will start right now. Okay. So I articulated the talk in 4 parts. First, we're going with a definition of what time series are. Then I will explain about human activity recognition, which is a topic in which I had been working for a while. And then I'll explain some similarity measures between time series, and we will conclude with some clustering algorithms. Okay. So my experience with time series is I worked in a project with a company in Galway called Woodruff Kenny for 18 months. It was a project for analyzing valves in the ocean, and also I have some publications. 2 of them are about human activity recognition, and the other one, yeah. And another one was about forensics and this thing. Okay, what are time series? Time series are sequences of numerical points, and normally they are sampled in successive order. Okay, and time series are all over the place. There are many examples of time series. We can track the air quality, the prediction of energy on a city, the traffic, our heartbeat, the number of birds in a given country, temperature across the year, text messages on WhatsApp. They are all time series. Time series, in one of the axes is time, and the other one can be different values. And we sample them across times. Okay. Number of views in YouTube, or how many people are going to visit your website, that can be also a time series. Now, in time series, there is an important concept called sampling, which is we have to take samples of the continuous values of a variable. I'm going to mute some of the guys because participants. Okay. Okay. Can you hear me well? You can reply in the chat, I think. So if you can hear me well, say yes. Okay, perfect. Now we were saying about time series. It is important to sample time series, which is taking some values from time to time. And normally there are 2 ways of sampling. One is Raman, which is every second or every 2 seconds or every minute. So always using the same time interval. That's called Raman. And the other one way of sampling is called Lebesgue. And Lebesgue consists of sampling depending on the value of the signal. So for example, here we have 1 point, and we are not collecting points here because the signal is not changing so much. Then here there is a bit of a difference, and then here again we will take another sample. So Lebesgue sample is more efficient than Raman sample, but is more complex to implement. There are some systems now that are using Lebesgue sampling to save energy, to process less information, and so on. So that's one of the main concepts in time series. Now, as I said, the surprises, I want to keep you awake. So here we have the first riddle, and the first riddle is you guys have to guess which number is below that car, right? We won't get too much time because we only have 20 minutes again, but which number is there? And it's a bit of lateral thinking. Okay, we won't go too long. Oh, people are saying something in the chat. Yeah, 87. Oh, people are smart. People are smart. Yeah. The answer was 87. Well done. Well done. I liked it. I like seen it before. Yeah. It took me a while. Well, I didn't get it. I didn't get it, but we move on. Okay, what is machine learning? Machine learning is a field of artificial intelligence that wants to make machines able to learn by themselves. So instead of doing a program, which takes a lot of time, we give the computer a data set, and the computer is able to detect patterns and behaviors and different things, relationships, and automatically the machine is able to create a new program able to perform different classifications. So that is machine learning, and it's very now it's very much on vogue. Now with time series we can apply both supervised and unsupervised learning. When we are classifying signals that supervised, or on where we are predicting the stock market based on the past behavior, that will be regression. So classification is when you are predicting classes. Regression is when you are predicting a discrete value. And clustering is when you don't have labeled data, and it is also interesting in time series. Now here, for example, we are predicting the stock market. We have the years, time, and we have price. And here it will be a regression example. Here it's a classification example, and it can be human activity recognition. So you have all these activities, and what did we predict? Drink, and if the real value was drink, that means that we are correct. And so here are the true values of the classes, and here is what we predicted. A good classification will have the diagonal values very high. Okay, I have to go quicker. Here, this picture that seems like the Batman is not the Batman, is an example of clustering. So we have the demand of bicycles, we have the demand on the weekends, and the demand on the weekends here, and the demand during week. During week it's 8 p.m. People get up very early, and on the weekends late. So we want an algorithm to automatically classify. That will be time series with clustering. Another riddle, guys, can you find a mistake in this time series? I just want to check if people are following. Okay, Fergal, you're very smart. D is 2 times. Can you find T mistake? Okay, well done. You got a prize. Well, don't take it literally. Okay, someone said didn't see that. Okay, can you find the mistake? The word D is twice, so that is the mistake. Okay, time series classification and activity recognition. Okay, so here is a nice example of time series. Imagine that we have a elder people and we want to track if the guy is moving or not, because we're very worried because he has arthrosis or whatever. So we have 2 options. Option one is intrusive sensors. We put a sensor to him on the wrist, on the chest, or on the ankle, and then we can predict which activity he's doing, sitting, standing, walking, or whatever. And the second option is just from the smartphone. The smartphones have also sensors, and we can predict which activity people are doing from their smartphone. So the process goes like this. At the beginning, the guy has different sensors, Bluetooth, GPS, whatever, and then that generates a signal. And as we said at the beginning, you have to sample the signal. So you have to sample the signal maybe in the time domain or maybe in the frequency domain. You extract some features from that signal. Once you have extract those features, you can train your machine learning models. Normally, you use 10 or 15 guys to do your training, and you use some guys in the training set and different guys for the testing set, and you can do that several times. Why you use different guys? Because the different guys will have a different height, they will have different speed, so you want to see if your model is able to extrapolate the knowledge from some subjects to the other subjects. And finally, you have to evaluate your model and see how good it is. There are different metrics. If we are performing classification, accuracy will be a good metric. Now there are different kinds of sensors, inertial measurement units, and there are accelerometers, and gyroscopes, and so on. All those give us information about how the guy is moving. They have different axes, and it's a lot of information. Now, because we have too many information, we need to process all that information. We need in some way to reduce the information. So instead of saying, let's say, 5,000 samples, we can calculate the max, we can calculate the mean, we can calculate the number of peaks, and that will give us a very huge reduction in the data set. So instead of working with 5,000 features, we will only work with 10 or 20. And that's like, and it also gives us an overview of the big picture, because we are calculating the average over 5,000 samples, which gives more information. There are different, normally you apply the Fourier fast transform, so you can extract features in both the frequency domain and in the time domain. And typical features can be the mean, the deviation, squeakiness, kurtosis, and the same in the frequency domain. Now, once we have extracted features, we have to reduce the number of features, and we do that by feature selection algorithms. What is the objective? The objective is reducing even more the models, make them more understandable, because the less features we are using, the more understandable models are, and finally, getting higher levels of accuracy. So there are different methods. Ones are filters, which are very quick, but they are not so accurate. And on the other hand, you have wrapper methods, which create models for different groups of features. So you have to create, first, I create a model with feature 1, 2, 3, then 1, 2, 3, 4, 5, and so on. And that is more costly from the computational perspective, but it works better, it gives better results. Deep learning algorithms have the advantage that you don't have to do a feature selection, they do it for you. So you save one step, and in the top of that, they have very high performance, especially when you have lots of data. The deep learning methods, they learn very slow, but where the other methods plateau, these deep learning methods, they keep learning. So they are quite efficient when you have a lot of data. Now here's an example. We are performing a feature selection, and we see that with 10 features, our model is almost perfect, and there's no point of using more features. So we will reduce our model to only 10 features. And here is the confusion matrix when we are doing classification, and you want to have all the numbers in the diagonal, which means that you are perfect. You are hitting the target. Okay. So here is the another riddle. And the riddle here is, how many matches are there? How many matches are there in the picture? It's not easy. Okay, 8. Another one says 8. I see some people are really smart. I don't know if they played before. Okay, the answer is 8, okay, and I will explain. 1, you can see the mouse, I guess. 1, 2, 3, 4, 5, 6, 7, and 8. And those 2 are reflection of those 2, so they don't count. So that the answer is 8. Okay, we keep going. 8 was the right answer. Time series similarity measures. Okay, so imagine that we have a data set, and we are very lazy because we don't want to manually label those data, and we want an algorithm to save. So we save time, and the algorithm works for us. So we have to evaluate if time series are similar, whether or not time series are similar. So the classical measure is Euclidean distance, which compare this point with this point, this point with this point, this point with this point, with this point with this point. It goes like that. So you see, blue and green time series are much more similar than blue and red. But if we apply Euclidean distance, the answer will not be this. It will be the opposite. It will say that red and blue are more similar. So there are other alternatives to Euclidean distance, and the most famous one is dynamic time warping. So dynamic time warping overcomes the issue that similar signals can be very similar, but because they present a shift, there is a shift in time, there is a displacement in time, they look different. So if you compare with the Euclidean distance, they will be very different. Why? But DTW is able to overcome this issue. And how does it work? Well, you have here 2 signals, Q and C, and you compare all the points of Q with all the points with C. And that one point with 1, 2, 3, 4, 5 to 20, second point with 1, 2, 3, 4, 5 to 20. You can see that the matrix is 20 by 20. And then you go from this point to this other point, going always in the square with the least distance, and that is the formula. That is the value. So dynamic time warping is very good, but it's very expensive from the point of view of computation. So there are other alternatives. So for example, symbolic aggregate approximation, which calculates the average of the signal, and it divides like the y-axis into letters. So the first letter is C, this area is B, this area is A. So you calculate the average and say, will this be recorded? Yes, it's going to be recorded. It's being recorded. So C is here, B is here, C is here again, and that is the average. So SAX, it's better than DWT in terms of time, computational time. And it has more or less the same results in accuracy. So again, you have 2 signals, blue and red. You calculate the average. You see in which position they are, A, B, or C. And then when you have the string, you compare the first position of the string with the first position of the other string, and that gives you a distance. That is the new distance. So this algorithm is performing quite well. To see which algorithms are better, you measure, you apply the algorithm of KNN, which is basically, you say that the class of this new item is the same class to which the distance is the smallest distance. So if this element, if this guy has the lowest distance, the least distance to this guy, the class of this guy will be the prediction. So it's, we can see it also as a classification. And there are different measures that have been designed to improve the accuracy. There is a portal called Time Series Classification, and it has loads of data sets. And then there, everybody tries his new method, his new measure, to see if it works better than the other ones. So it's like a benchmark. Okay, another riddle, which is, where is the bus going? Is the bus going right, or is the bus going left? And the bus is an Irish bus. Okay, I think that now I caught you. Some people say left, some people say right, some people left. Okay. And the answer is, it's an Irish bus. So some people say it's not moving. Okay. It could be that it's not moving. That can be another answer. But the answer is, the bus is going right. The bus is going right. Why? Because the door is in the other side. Okay. So if it was an American bus, it will go left, because the door is in different positions in America to Ireland, but that's why I said it's an Irish bus. So it's going right. Okay. It's a bit tricky. I'm not very good at guessing riddles either. So if you didn't guess anyone, don't worry. I mean, I'm with you here. We're finishing. We only have 5 more minutes, but because the riddles, we will give 3 more minutes. Okay, last is clustering. So clustering is about when you have time series and you have no labels, you want to perform algorithms that automatically classify your time series. So imagine you have the Simpsons. Partitional will be doing different groups, and hierarchical will be like seeing the relationships in terms of a hierarchy. That's a difficult word to pronounce in English, hierarchical. Now here is my time, here is the time series, all my time series. You can see that there are clearly 6 different groups. This is not a riddle. 1, 2, 3, 4, 5, then 6. And we want our algorithm to automatically identify those groups. So we run hierarchical clustering dendrograms, and there you have it. You know, you have 1 group, 2 groups, 3 groups, 4, 5, and 6. And I guess that the red ones are this one and this one, which are more similar. So it's the more similar they are, the closer they are in distance. So these ones will be more similar to these ones than to these ones, and that's how it goes. So that is hierarchical. And the other one, the other approach in clustering is, imagine we have a k-means clustering, and then k-means clustering, we have to identify again the 3 different groups. So how can we do that? Well, we can run the k-means algorithm, which calculates the centroids, and we will see it visually, which is much more the algorithm works as follows. First, we randomly say, imagine there are 3 groups, because that's one of the parameters that we have to say, and that is one of the issues of these algorithms. We say, imagine there are 3 groups. Okay, so randomly we fix the centers, and then we have to decide, and then all the time series that are shorter in distance to that point are categorized as the class to that point. And that's very difficult to express, but we will see it visually. The thing is that for calculating the distance, you can use different measures. You can use SAX, you can use Euclidean distance, or you can use DTW. But here imagine that we have different time series. One is red, the other one is yellow, the other one is blue, and randomly we pick 3 centroids. So it will go as this. The centroids are moving, and we want until they get to a point where it doesn't move and they stay there. So our model will say, okay, this one belongs to one class, this other one to the other class, and this other one to the other class. It works. It works quite well. It's quite efficient. And the process is that you have to set the number of clusters, and it doesn't handle noise or outliers. So this was it for today. And as it couldn't be okay, here is the last riddle, and then if you want, you can ask questions, and there will be no more riddles. So this is your last chance. Which number is missing? Okay, I think that this one you didn't know. Okay. There's always one smart guy. Welcome. Well done. Well done. Well done, guys. 26. That's the number. Very good. Okay. So I guess this is the presentation. Time is more or less. It's 11:30, so we're on time. And I don't know. I muted you all. Try to mute you.
Yeah, Dad.
Hello. Edward or someone, any question?
Hello.
Hi.
Hello.
Hi, it's Aaron. Can I ask a question, please?
Yeah, go ahead.
How are you? Thank you for the presentation. It looks really interesting. I'm really interested in this. I'm just wondering the point of feature selection side. Actually, you mentioned that the selection of features is really quite important. And as much as you select the feature, I mean, decrease the number of features, it will be better. I'm just wondering, as you know, feature engineering is really one of important points in terms of accuracy or ROC or AOC. I'm just wondering how could be integrated feature engineering in terms of, let's say, there are some hidden features to see them maybe combining with the former features, So yeah. I'm just wondering this topic on time series, if you have time.
Yeah. So the thing is that
still trying to get.
I'm going to mutate all again because the other day. So time series, especially when you have a lot of sensors, it can be a bit overwhelming because you have too much data and it's not very efficient. So in order to do efficient applications, let's say, for example, smart watches that want to know your activity, and that information, you want to select the least possible features because that is information that you are going to send. And the less features that you select, the less information you are sending. So that is good for saving the battery of your phone, for not collapsing the network. And imagine all the smartphones that are in the world. So in some applications, it's really useful to try to avoid using filter extraction as much as possible. So there is always a trade-off. If you perform your model with all the features, it's going to perform well. But when you are doing applications, you want them to be very efficient. So then, depending on how many people are going to use or for how long your application, you will try to reduce the number of features as much as possible. So for that, there are wrapper methods. There is recursive feature selection. There is a NSCA algorithm. I never remember very well like the acronyms, but there are a lot of publications about wrapper methods, which one are more efficient. It's like an optimization problem. Filters are very good, but they won't give you the best answers. But if you want to, if it's just an application that a program that you only want to calculate the performance once every year, there is no point, for example, in applying a very heavy method. You can write me an email if you want, and I can give you some examples or whatever.
Oh, you got batch bread.
Hello?
Hi, thank you. Thank you so much for the comment.
Okay, so I don't know who's, it's not easy to. Okay, guys, is there any other question? And if not,
Hi, Lewis. It's Fergal Toomey here. I have one question I'd like to ask you. Thank you very much for the presentation. It's very interesting. So my question is, do you have a sense of how much domain knowledge is typically needed to apply these different techniques to practical problems? And are there some techniques that generally work better than others when you don't have a lot of domain knowledge about the specific problem area that you're dealing with?
well, I will recommend you. I think there are there are different algorithms that you can use, and if you type time series in Google, there are different blogs that give you examples, and there are always implementations in Python and in R, but much more in Python. Python has different libraries that you can use. Don't ask me for the names because I'm very bad for names, but there are a lot of libraries for time series that they are already implemented, and there are examples that you can use. So with a relatively small effort, you can get very good knowledge. But you have also you have to have like the big picture. So try to understand those methods, and there are very good explanations as well in YouTube. But I think that you have to have a small overview of time series, how they work, and know which are the main methods, and try to find implementations online, and then practice and practice and practice, and then you get there eventually. I don't know what else can I say. So.
Okay, thanks.